Welcome. We will now start solving numericals on this topic of equilibrium. Unit 5, if you are referring to syllabus of University of Pune, first year engineering mechanics, Unit 5, topic is equilibrium. This is the first problem. And the problem states that there is a circular disc. The circular disc, one end of the circular disc is attached to wall by a rope, this is a rope, and the other end is attached, the rope is tied to the center of the disc, okay, and the disc has weight of 1000 newtons. Fine. The disc is resting against the wall, right? So you are asked to find out what is the tension in this rope. Tension in this rope. This is question number 1. You are also asked to find out what is the reaction, the magnitude and direction of the reaction from the wall. Now see, when you face problems, this is a problem coplanar system, and you have we'll see how many forces are acting. But when you have problem of where the body is under equilibrium, the steps which we will follow through are as follows. Number 1, you will isolate the body. That means you will isolate it from the wall, from the rope, right? And just subject the body to the forces, right? That is called as drawing free body diagram. And then you can find out the angle. Second step is, we can say, in a compact way, you can say it's settling the geometry. That means you will find out the angle which all the forces make with the horizontal, right? With the horizontal. Right? That's a second step. And then, since the system is under equilibrium, right, you can immediately say that sigma fx is equal to 0 and sigma fy is equal to 0. Now that gives you, because unless that condition is not satisfied, the body cannot be under equilibrium. Okay. So let's consider how many forces are acting on this body. And you can see that the body has weight. The weight has to pass through the center. Right, and so let's say this is passing through the center. This is 1000 newtons. So this is 1000 newtons. So if I want to draw the free body diagram, what I will do is I'll remove this wall. I'll remove the body from this basically wall, and I know that there is a rope, right? And from that rope, through that rope has to pass a force. What kind of force? See, this is a rope attached here and the disc is hanging here. That means it is pulling the rope, okay? It is pulling the rope. So the rope is subjected to a downward force at its tip and an upward force. Why upward force? Because when the rope is acting, the force is transmitted, this downward force is transmitted to the rope, to the point. The point, as per the third law of motion of Newton, it will be giving a reaction in opposite direction. So the rope is pulling this point of attachment, but the point will pull that rope away, right? So if you draw the free body diagram of the rope, this is the rope, the force has to act downwards in this way and upward, right, along the line. So that's a free body diagram. But we are drawing the free body diagram of the disc, okay? So when you consider disc, obviously, the disc is pulling the rope and the rope is pulling the disc, right? That's reaction from the rope. So, and this is the force away from the disc, understand this clearly, away from the disc, and this is the force of tension, okay? This is the force of tension. Similarly, the vertical surface, see, normal force when the body is resting on the ground, as we have discussed in the earlier video, it will give a normal reaction that will be normal to the surface. Here the body is touching tangentially to this wall, so the normal reaction from the reaction from the wall will be normal to this tangent in the sense that surface which is tangential to the surface, tangential to the circle. That means, see, that this force will be acting towards the center. Why towards the center? There are two ways in which you can arrive at this. There are three forces, 1, 2 and the third force, and the body is under equilibrium, which means all the forces have to pass through a single point. That's rule number 1, okay? These two forces are passing through the center, because the rope is attached to the center, the weight will act through the center. The third force also has to pass through the center. That's logic number one. Second logic is that this is a circle, this is the tangent, the surface is tangential. The normal or perpendicular line drawn to the tangent has to pass through the center, right? That is also one logic. So your reaction is going to be toward the center. We'll call this R wall, right? I'm removing this wall, so this becomes a free body diagram, and I can take this force in this way. So this is RW. You are asked to find out T, you are asked to find out RW. Now, when you want to find out this, you want to find out the angle of all the forces with the horizontal. Now, this is in horizontal direction, angle is 0. This is perpendicular, right? So, angle is 90 with the horizontal. What about this? To find out that angle, consider, see the total, if you see the total length of the rope is 40, right? Radius of the circle is 20, and if I join this line, we want to find out this angle. Naturally, this angle you can find out adjacent by hypotenuse. This is 20 by 40, right? That is going to be cos of that, cos of half, cos theta is equal to half here. That means theta is 60. So this angle, right? This angle is 60 degrees. Fine. So that is settling geometry. Now you are going to apply, let's say, we apply sigma Fy is equal to 0. Sigma Fy is equal to 0. Now see, a resolution of forces. This is T, right? And it is away from the center. Resolve, first when you want to find out horizontal, vertical component, it is going to be sine of the angle which the force makes with the horizontal, right? So it is going to be T sine 60. T sine 60. That's the resolution in vertical direction. What will be its sine? Look, this arrow is away from the center. When you resolve it vertically, this is the vertical axis, it is going to be away from the center. That means upward. It's going to be upward. So this is going to be plus. Then with only the horizontal force, RW will have no bearing on vertical resolution. The only other force is acting downwards, so it's negative 1000 newtons. So minus 1000 newton. This is equal to 0. I don't have to write newton. Minus 1000 is equal to 0. So when you solve this, you will get T is equal to 1154.73. 0.73. This is T. You got first answer. Now you resolve it horizontally. When you resolve it horizontally, that means sigma Fx is equal to 0. What do you do? This is T cos 60. It will be look at this. This is away. When you resolve it, it's going to be towards left. Left we consider generally negative. So it is T cos 60, right? This will have no bearing on the horizontal resolution. Towards right is RW. This is towards right, and so it is going to be plus RW is equal to 0. When you substitute the value of T, which we have found out in the initial step here, find out RW, and that RW will be 577.36. So that's your answer. So we have started with a simple problem, but understand especially the tension, how the tension force is represented on the body. That's very, very important. And remember those steps, okay? So keep on visiting this channel. We will solve many more problems and of higher, increasing complexity. Thank you.